The Quezon Memorial Circle has a shrine with three 66-meter pylons that represent Luzon, Visayas, and Mindanao. The number 66 also happens to be the same age that former Philippine President Manuel L. Quezon died. Coincidence? Some people even think that the remains of Manuel Quezon can be found inside the shrine. And they'd be right. Another interesting characteristic of the Quezon Memorial Circle is that it is found inside a traffic circle called the Circular Road? No, the Elliptical Road. Clearly the traffic circle is circular, but is the elliptical road really elliptical?
Hey, Vsauce! Brian here. What is an ellipse? Is it this, or this? Let me demonstrate how an ellipse is made with a single string pinned down to 2 points. Notice how as I move around this pencil with a string, a shape is formed. Note while the length of the string stays the same, the length of the sections on the right and on the left of the pencil change. As I move the pencil to the right, the left side gets longer and the right side gets shorter. However, the length of the whole string stays the same.
An ellipse is a regular oval shape traced by a point moving in a plane so that the sum of its distances from two other points, the foci, is constant, or resulting when a cone is cut by an oblique plane which does not intersect the base. The line along the longest diameter of an ellipse is called the major axis, while the line along the smallest diameter is the minor axis. They intersect at the center of the ellipse. The points where the ellipse intersect with the major axis are called the vertices, while the points where they intersect with the minor axis are called the covertices. The foci are the 2 points on the major axis that are equidistant from the center. They serve as the reference points for the creation of the ellipse.
An ellipse centered at point 0, 0 can be represented by an equation x squared over a squared plus y squared over b squared equals 1, where a is the distance of a vertex to the center and b is the distance of a covertex to the center. When an ellipse has a vertical major axis, a becomes the denominator of y and b becomes the denominator of x. To move an ellipse h units to the right, subtract h units from x in the standard equation. To move an ellipse k units upward, subtract k units from y, making the standard form look like this: x minus h squared over a squared plus y minus k squared over b squared equals 1.
But how is it derived? Well, let's go back to the definition of an ellipse.
An ellipse is a regular oval shape traced by a point moving in a plane so that the sum of its distances from two other points, the foci, is constant.
Now, with this, let's make a working equation. The constant sum of the distances equals the distance from one focus to the point on the ellipse plus the distance from the other focus to that same point. Then, let's plot a horizontal ellipse with its center being on the origin. Now, let's first figure out the constant sum of the distances. If we mark the distance from both foci to a vertex, we can figure out the distance of these lines in terms of a, the distance from the center to the vertex, and c, the distance from the center to either foci. With this, we can figure out that the shorter distance is a minus c long, while the longer distance is a plus c long. And if we add them together, their sum would be 2a. With the vertex being a point on the ellipse, by definition, for any point on the ellipse, the sum of their distances from both foci would be 2a. Now, for the distances from the foci to any point on the ellipse, we can use the distance formula to get them. With the foci at coordinates negative c0 and c0, and the point on the ellipse as xy, we can plug in these coordinates to get the distances. Lastly, if we substitute what we got to our working equation, we can now simplify this to get close to the standard equation. And if we substitute a squared minus c squared such that it is b squared, you would get the standard equation of an ellipse that we have used. And that is how it is derived. Back to you guys.
Eccentricity is how an ellipse deviates from a circle. The closer the foci are to each other, the closer the ellipse resembles a circle.
Now that we know what an ellipse is, let's put the elliptical road to the test with the help of some graphing software. As you can see, the elliptical road matches the equation x squared over 3.5 squared plus y squared over 2.7 squared equals 1, with foci on points 2.220 and negative 2.220, making it truly elliptical. In conclusion, the Quezon City elliptical road being elliptical is confirmed.